All right, so here we are with lesson 1 for unit 2, square roots and cube roots. All right, so the three expressions with exponents are given below. Each expression, label the base, the exponent, explain the mathematical meaning by writing in expanded form. So you probably remember this from way back in the day, 5 to the third power, okay? We would call the 5 the base, okay? And we would call the 3 the exponent or the power. All right, and now some people get confused by this because one thing you're going to hear me say often during this unit is that this right here is not a number. Okay, that 3 is an indicator of how many times we have the number 5 written. 5, oh, sorry about that. 5 times 5 times 5. So where do you see the number 3 in this expression, right? It is not there. Okay, so again, the 3 looks like a number, but it does not behave like a number. Okay, it is an indicator of how many times we have the base. All right, what about this one here? M to the 5th. Okay, m to the 5th is going to be m, 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 m. All right, and then we have 100 squared. Okay, so 100 squared, again, this is the base, right? All right, and this is the exponent. Okay, so 100 squared would be 100 times 100. All right. So if we expanded that, right, we would get 100 times 100. Okay, now some of these that are integer values, right, we can also simplify them too. So this would end up being 10,000 if you were asked to simplify it. Okay, so similar to the inverse operations for addition and subtraction, raising a value to an exponent also has an inverse operation. That's called a square root. Squaring a number is raising that number to a power of 2 or multiplying it, all right, by itself. The square root is an inverse operation, all right? So you heard me say the undo, okay, when we were solving equations last chapter, same idea. Okay, the positive square root is what we call the principal square root, and typically that is the answer that is given. Okay, so the square root of x means that what we're trying to think about there is what number times itself would give us x. Okay, so here's a couple expressions to evaluate using squares or square roots. Obviously, you can always use your calculator, but I'm going to encourage you to do things by hand as much as you can. Okay, so 15 squared is actually 15 times 15, and that equals 225. Okay, next up here we have 144. So what I'm trying to think to myself is what number times itself would give me 144. In this particular case, that would be 12 times 12. So the square root of 144 is 12. All right. Next up here, we have negative 6 squared. Now you got to be really careful here because on your calculator, I want you to type this in both ways. I want you to type in negative 6 squared, but then I want you to type this in with the negative 6 in parentheses. It's going to give you two different answers. Okay. We need to make sure we always use parentheses, okay, when we're talking about negatives. All right, so negative 6 squared is negative 6 times negative 6. Math class only, two negatives make a positive. This ends up being 36. Okay, and last up, 49. So this is one you probably have memorized. What number times itself gives you 49? In this case, that would be 7. Okay, so the reason we learn about this is so we can solve equations, you know, in next chapter when we do equations that have squares in them. So in the first one here, if x squared is 81, how would we solve that? We would want to do the inverse operation. It's no different than previously where we had plus. We're going to do the opposite, which is minus. Okay, same principle here. So I'm going to take the square root of both sides. Okay, and I end up finding out that x equals 9. Okay. M squared equals 9. So same idea. I'm going to square root both sides. All right, and the square root of 9 gives me 3 for m. All right, and then last up, I have f squared is 400. So same principle here. I'm going to square root the f. Okay, and the square root of 400 is 20. I can always check myself too by saying, okay, what is 20 times 20? Yes, that equals 400. All right, let's turn the page, okay? Cubing a number is very similar to squaring a number, except now we're talking about a power of 3, okay? Or we're multiplying it by itself 3 times. Again, the cube root is an inverse operation to get rid of cubing something. All right, will you have as many of these memorized as you do perfect squares? Probably not, okay? So you can fill in this table with me, or you can push pause and fill it in yourself. It's entirely up to you, okay? But we're going to go ahead and fill in some of these cubes. All right, just because they are a little less familiar than squares. So 1 cubed is 1, 2 cubed is 2 times 2 times 2, right? Just so you know, that's how we're getting all these answers. Okay, so that would actually give me 8. All right, so 3 cubed is 27, right? So 4 cubed is 64. And again, I'm taking 4 times 4, getting an answer, then taking that times 4. Okay, 5 cubed is 125. All right, and then some of these up here, you may or may not have all of them memorized, okay, like you would for hopefully squares, all right, but 6 cubed is 216. Okay, 7 cubed ends up giving me 343. Okay, 8 cubed gives me 512. All right, 9 cubed gives me 729. And 10 cubed gives me 10,000. Or excuse me, 1,000, not 10,000. All right, so we would do the same thing for squares, right? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, so forth. So we know squares and square roots. All right, so when we're solving this, okay, solving these, we can use our calculator. Now, your calculator might have a cubed root button, but if it doesn't, you're going to be using the X root. So if you look at your calculator screen, you're going to see a button that has a little X with a root like this. Okay, so we would want to type in the number 3 first, and then we want to hit the X root button, and then we want to type in 512 and hit enter. And that's how we would calculate the answer to this on our calculator. So make sure you can locate all those keys. All right, so this gives me 8. All right, negative 5 cubed. Now remember here, since it's cubed, we have negative times a negative times a negative. So we actually end up with a negative answer here, negative 125. Okay, cube root of 16, again, just to refresh there, you're going to type in the number 3 first. You're going to use the X root button on your calculator, and then you're going to type in 216 and hit enter. Okay, and that's going to give you 6. And last up, 1/4 cubed, okay? Anytime you're cubing a fractional value, clearly you can always use your calculator, but one thing I want to teach you is that by hand, you would just cube each parts of this, okay, separately. So 1 cubed over 4 cubed ends up giving me 1/64. Okay, now the calculator probably gave you a decimal for that if you used it. Same principles down here. When we're solving a cube, an equation has a cubed variable in it, we're going to take the cubed root, okay, to do that. That is the inverse operation. All right, so when I do the cubed root of 64, okay, for this one, I'm going to get p equals 4. All right, and again, I'm using the X root button on my calculator, typing in the 3, the X root button, and then 64. All right, very similar over here, cube root of 1,000. Okay, cube root of both sides, so n gives me 10. All right, and then next up here, I have the cube root of each side here, so g gives me 5. All right. Last up, we have 2 word problems here. So Trisha's Treats is a local bakery, has a square menu on the wall that covers an area of 900 square inches, or an equation that could be used to find the side of one length of the sign. Okay, so if it's square inches, right, that would be 2. So s squared would have to equal 900. Okay, so again, that's the whole idea here, is that we got to know what shape we're talking about. Okay, in this case, it's a square menu. All right, so then what is the length of one side? I would want to take the square root, okay, of both sides here, okay, to get my answer. So if s squared, if s squared equals 900, right, I would square root both sides, and I would find out that the length of one side is 30. And label this, because the word problem, inches. All right, now volume is different, right? Volume is 3-dimensional, okay? So that's where the cubed comes in play here. So an equation can be used to find x, the length of one side of a cube, right? So we would say that x cubed equals 729, okay? And then if I'm solving for that, I would take the cubed root of both sides. So remember, I'm going to do the number 3, okay? I'm going to use the x root button and 729 to find out that x has to equal 9 inches. All right, so pretty easy lesson here for today, summarized out there at the bottom, and I'd like you to go ahead and work on your homework that corresponds to this lesson.